Welcome, and thank you for coming to Morgan State's School of Architecture and Planning's Fall Lecture Series. That's right. This evening's special event was arranged by the Morgan State chapter of the American Society of Landscape Architects, the ASLA. My name is Chris Schoenster, president of the Morgan State chapter of ASLA. Our featured guest speaker is Isaac Hametz, the research director at Mahan Rykiel here in Baltimore, who will be later joined by a second guest, Kristen Keene of the Maryland Port Administration, to help with a Q&A at the end of the presentation. Isaac Hametz oversees Mahan Rykiel's design research portfolio, building strategic partnerships to advance innovation in landscape architecture and urban design, and facilitates transdisciplinary collaborations among public, private, and nonprofit partners, manages project-based performance specifications, integrates design research methods into office practices, and disseminates research and educational publications. Working closely with client colleagues and collaborators, Isaac targets design research opportunities that focus on economic development, ecological stewardship, and social equity. In support of Mahan Rykiel and its partners, he draws upon his background in agroecology, landscape systems, community development, and nonprofit management. So without further ado, I'd like to introduce our featured guest speaker, Isaac Hametz.
Thank you, Chris, and thank you to the department for hosting me this evening and for welcoming me to the CBIS building. So you guys got a great building, great program, so it's an honor to be here. So a lot of slides, and I'm hopeful to kind of have some Q&A opportunity at the end, so I'm going to move through them quickly. If you guys have any questions, kind of jot them down, or honestly, feel free to also, it's a small enough crowd that if you want to pause, if there's something that's not clear, stop me. It doesn't have to be kind of totally kind of frontal in that way. So before jumping into the content, I do want to thank my office, the Maryland Port Administration, there we go, Maryland Environmental Service, Anchor QEA, Cornell, research teams that we have had in the office the last 2 summers. There's a third group that will get added to this as we continue to do this. This is kind of an ongoing design research, body of design research that we're working on. And it's really a collaborative effort. Everybody who's listed here is really kind of a co-author in the work. I just get to be, have the fun of kind of moving it along and kind of guiding the work as we go forward. So if you don't remember anything about the content of the rest of the slides, these 3 kind of words are important. So as a landscape architect, I think it's important to remember that we are a material discipline. We use ideas and concepts to shape real things that have kind of their own embedded intelligence, material qualities, and that's important, and it's something that we want to keep at the forefront of the conversation tonight about sediment and dredge material. How do we work with the material? How do we understand its inherent logic, plants, stone, wood, all the things that we ultimately shape as designers? They have their own inherent qualities, and so think about materials in that kind of way. The next one is method. The ways in which we shape these materials, the tools and the techniques we use are not neutral. They define in some ways the outcome of the product, of the places that we create. So when you're drawing something, the representation is not neutral. You're conveying certain ideas through the drawings, and you're also, when we're using machines, and Kristen, who's here, everybody say hi to Kristen, can attest that when we were working kind of through some of our iterations this summer on pilot project for Hart Miller Island, we spent a lot of time thinking about the excavators. So the methods and the tools really do shape how we ultimately design. And kind of lastly, the idea of experience, that as designers, we're not engineers. We're not solely looking for performance specification. We are also concerned about aesthetics and what that means for the built environment. So we care a lot about performance. How do we make space that works, that functions ecologically, that functions socially, that functions economically, but we care about the aesthetics of the experience as well. And so to kind of jump into the more messy side of things, I want to offer this quote from Jane Bennett. She talks a little bit about, this is kind of her describing her own awakening to the power kind of material things. And so she says, "But they were all there just as they were, and so I caught a glimpse of an energetic substantiality possessed by each these things that I generally saw as inert. This opening was made possible, the fortuity of that particular configuration, but also perhaps by a certain anticipatory readiness. And for me, this reminds me of the fact that things, again, have this readiness. They have inherent intelligences, and we as designers are kind of asked to kind of guide them in different ways. And so when I think about sediment through this lens and through kind of the landscape lens, it's the stuff that kind of serves as the substrate for healthy coastal ecosystems, marshes, wetlands. It's also the kind of substrate of our cities, our coastal cities. But it also is the stuff that ends up in the shipping channels that the port and Army Corps and partners have to pull out, causes kind of negative externalities for kind of the economics in the area. And that too much sediment in the water column also ends up creating turbidity and is a negative externality and a negative side of sediment. So it has this kind of anticipatory readiness. It is both the fundamental substrate of healthy coastal ecosystems, but it's also the stuff that gets in the way of the economy of the port and its operations. So how do we begin to grapple with this kind of material in a design format? And so looking at the material that's coming into the Chesapeake Bay watershed, it's 64,000 square miles of watershed, stretches all the way up to kind of Cooperstown, New York, and is kind of being spit into the Chesapeake Bay through runoff, sediment loads, through shipping channels and through the channels themselves, sloughing off of angles of repose in the channels themselves. There are a number of these different sources of sediment. And the material that we've got, again, kind of coming back to that material idea, is it's mostly silts and clays, which makes it a really challenging material for agricultural uses. It doesn't have an organic fraction. It's very limited in terms of its horticultural applications as such. And because it is poorly graded, it lacks compressive strength. It's all kind of the same size. And so that creates a series of kind of challenges. And so more than the material, though, that what's driving this operation, this dredging and this sediment is the economics of the port, which has 175 miles approximately, give or take, Kristen, of shipping channels, from the Virginia mouth of the bay all the way up to the C&D Canal, that has to be kept open to support the Port of Baltimore, which kind of in terms of dollar value is the 9th largest port in the country. So the economics of dredging, more so even than the material, drive the methods and the output of this process. And so what that looks like, and some of this is faded out, we'll get to what this looks like a little bit later, but what that largely looks like is kind of scooping material out of these shipping channels, transporting it usually via barge to placement and processing facilities, to kind of these sediment landfills. And that has largely driven kind of a landscape machine, if you will, regionally, that has dramatically changed the shoreline of the Baltimore kind of metro region. And everywhere that you're looking at here that is red is an area that has been built using fill material, a lot of it being the sediment that's dredged from the harbor. Some of it also includes kind of rubble and things like that from the fire, Great Baltimore Fire. But a lot of it really is being driven by this landscape machine, this dredging operation. And what that ultimately looks like on the ground in terms of an experience, this aesthetics of dredging is these port terminals that are really driven by a kind of throughput logic and industrial logic that guides materials in and out in the most efficient way possible. And it's an amazing space, thing to kind of witness in terms of its scale and efficiency. But it kind of generates these types of, or we've generated these types of collages to kind of begin to speak to what that experience is like, a kind of experience that is, again, not driven by an eye towards design, but driven by an eye towards a particular method and what we can do with a particular material. And they're kind of sublime in that, the scale of these, the coal piles or the salt piles or the cranes or any of these things, the tracks that are made are kind of awe-inspiring in their scale, that have nothing to do with the human body. And so it's an amazing kind of relationship between the material, the method, and ultimately this kind of experience that, again, is kind of ancillary output of the process. And so, in addition to the port terminals, there are a number of other kind dredge material containment facilities, what we call them, kind of in Maryland, they're called CDFs, confined disposal facilities in other areas in the country. We have some unique terminology in Maryland for these types of landscapes that are kind of nuanced in other parts of the country. So what you see kind of over here is Hart Miller Island, which is a closed facility, Masonville Cove, which is kind of active and open, Cox Creek, which is active and open. And those are the main kind of disposal facilities, sediment kind of dumps, if you will, for these operations regionally. And what those look like, also kind of similarly in terms of their aesthetic experience, they're very similar, or they have their own logic, the same way that the ports terminals have this very specific aesthetic experience. And these, you can see there's this kind of merging of ecological systems, kind of this littoral and kind of wild natural environment with the scale and machine logic that you get from dredging. And so this is kind of some images of Hart Miller Island. The Cox Creek dredge material containment facility has a similar type of scale and character. And Masonville Cove is a little bit different because it both includes, some of the images here, both includes the actual containment facility as well as kind of an sister site, which is the Masonville Cove Environmental Research Center, that we call Environmental Education Center. So, and so it has some qualities that begin to speak to kind of a human experience through living shorelines and other types of engagement opportunities that kind of step beyond the kind of, again, this industrial logic of the port. And so kind of this is a picture actually out at Poplar Island, kind of further south in the bay. But it speaks to, again, that question I posed, or that idea, kind of the anticipatory readiness of the material. It is both, this just, raw sediment that can be either the substrate of coastal ecosystems, but it could also be this negative material, this kind of blockage in the channel system. And it can be, like I said, restored. And this is on Poplar Island, literally two sides of kind of an access road. You have these two different expressions of the material. So the question is, how can we utilize this material in a way that ultimately kind of supports a broader set of methods, or a broader set of concerns beyond simply the economic necessity of keeping the channels open? Can it begin to address kind of social issues regionally? Can it begin to address some of the ecological kind of questions that we have living in Chesapeake Bay, obviously the nation's largest estuary? And can it begin to kind of hybridize or connect these concerns in a way that also helps to mitigate against climate change and some of the kinds of things that we're all watching relative to Hurricane Florence, things that are really going to be pressing here. I think statistic is that in outside of coastal Louisiana, these areas down here in Maryland are going to be the second most chronically flooded places in the country by 2050. So, and again, that's not just from a 30,000-foot planning perspective, but what does that mean ultimately if we begin to yoke these questions together of the economics that the port kind of guides commerce through, but the social values, the ecological values, what does that look like, and what that might begin to feel like, through the prism of kind of Baltimore as a cultural landscape, as an artifact of years of development and history and all of those kind of pieces. And so, again, looking at it through the experiential lens, not just kind of a 30,000-foot lens. What does this begin to look like? And how might it begin to address the loss of marshes, chronic flooding events, and things of that nature? And so, when we were working with the port, the two items, kind of these are a set of kind of criteria maybe that you might look at when thinking about the possibility, the opportunities for using dredge material in innovative and kind of beneficial ways. That the bookends are kind of volume and cost. How much material can we get rid of, can we utilize, because it's got to get out of the shipping channels, and how much does it cost? Ultimately, this is the port kind of stewards taxpayers' dollars, and so the question is, are we using this efficiently? But then, these other criteria might begin to help us guide kind of opportunities. So does it bring in stakeholders? Can we use this type of landscape, kind of connected thinking, to bring additional stakeholders to the table, can begin to provide social value, ecological value, and ultimately visibility, because much of this landscape machine is kind of hidden in plain sight. The machine moves all this sediment, and it kind of goes to places that most people don't have access to, whether it's under a port terminal or an island, in the bay. These are places kind of far afield, and so folks who don't have the opportunity to get out there, I think would benefit. We'd all kind of benefit from understanding a little bit more about how we operate in this in this estuary. So, can it be more visible too? And so, when you think about that, and this is something that the port has been working on a lot and has made really significant progress from a policy and a regulatory perspective, is looking at alternatives to this just placement and processing. So moving beyond these dredge material containment facilities to beneficial use projects where the material, where it's not really effective as a soil for agricultural use or construction necessarily as such, maybe it can work for the restoration of wetlands, because wetlands are typically very silty. They have a lot of silt and clay content. You're kind of matching where this material might otherwise end up if it wasn't ending up in kind of shipping channels. So beneficial use opportunities. How might we reuse this for ecological opportunities? And then there are things like innovative reuse, which really just kind of the distinction in the state and is primarily beneficial use, is looking at aquatic uses like wetland restoration. Innovative reuse is really looking at on-land terrestrial applications, and that might look at things like, instead of bringing fill material to cap landfills and kind of daily cover, at the end of a day you got to put a daily cover the material that you've placed. So can this material begin to be used in that way? Can it be integrated or mixed with other aggregate materials, other waste stream materials, to use as a kind of structural base for road beds? So when you start thinking about this material and methods for reusing it that begin to address kind of social, ecological, economic issues, a range of possibilities emerge in terms of how it might really be integrated back into the social kind of landscape system here in the Baltimore kind of metro Chesapeake region. And so, I'm going to, obviously, as a landscape architect, kind of front landscape architect's role in this, in terms of thinking about like what we do here, and it's really trying to kind of come at this not as the engineer, right? We're kind of one of the last great generalist professions where we kind of synthesize a lot of things, where we try and connect the dots. And so, we've been working with the port and others in this process, really trying to understand this from a community perspective. How does dredging and the beneficial or innovative use of dredge material, how is that perceived by community members? What does that look like? How do educational institutions, government agencies, industry experts, how do we all kind of work together to try and kind of move the needle forward? And for us, that has included kind of a range of methods from material kind of testing, including things like looking at seed balls, applications of kind of, almost like guerrilla gardening restoration products, really testing materials, to kind of regulatory meetings and conversations, to field visits, to kind of community engagement, to kind of just looking at the aesthetics. Like one of the interns actually picked a wildflower bouquet from a dredge material containment facility. So kind of thinking about this again from a set of hybrid methodologies that help broaden kind of our perspective on what's possible, how we might draw out the material intelligence of kind of the sediment. A shout out to Fred and Marion in the photograph, top left corner. So kind of drawing back for a minute before I show some of the ideas that we're working on, why does this matter in Baltimore? Why is the Port of Baltimore even such an important thing here? Why Baltimore, right? This answer is it sits at an important kind of geological kind of split between kind of the Piedmont Plateau and the coastal plain. It's kind of the area where the head of navigation where boats could kind of had to stop. They couldn't travel up past the fall line. You could harness kind of the power of the falls that were kind of shifting from this kind of geological rock to kind of the sedimentary outwash of the coastal plain. And so there's a lot of cities along the East Coast that kind of occupy kind of this geological niche for the sake of city building efficiency. And So Baltimore did it, and Baltimore's kind of grown up because it's has a strategic advantage in terms of being the most western port, so it reaches these western markets more quickly and more efficiently than some of its larger ports up and down the eastern seaboard. And over the years, the port has shifted in terms of kind of being a port that's really driven by agricultural products, down here, to kind of privateering, war effort type stuff, to the industrialization that we all kind of know well about, to kind of a really, again, a major player in the U.S. global kind of commerce in terms of moving cargo. I think we're number one in the nation in terms of roll-on, roll-off cargo. We move more kind of trucks, heavy machinery, tractors, things like that than any other port in the country. And as a result, the shipping channels have shifted in terms of their scale. So, when we started, actually, Baltimore created the first dredging machine called the Baltimore Mud Machine. But as the scale of the ships have grown, the depth and width of these channels. This is a diagram kind of showing the depth and width of different channels. So the Swan Point Channel has kind of started in the mid 1800s and has gotten deeper and deeper and wider to accommodate this shift in shipping and just the markets. And so what that's done is kind of taken us from a colonial port at the mouth of the Jones Falls to a kind of a massive infrastructural landscape that includes multimodal systems of highways, railroads, and shipping channels that kind of scale across the region. Again, kind of what that looks like in terms of keeping those channels open is this number I know is shifting a little bit, but when we drew this, it was 1.5 million cubic yards annually just from the Baltimore Harbor Channel, not the entire 175 miles of the Chesapeake Bay, but just the shipping channel in Baltimore Harbor, 1.5 million cubic yards, and you put that on the Star Fort at Fort McHenry, it's about 140 yards high. So it's a massive quantity. It's a large amount of material. Large material is also kind of matched by a large kind of government structure to make sure that the material is managed efficiently and effectively. And what you'll see here is actually Baltimore gets a lot of credit actually nationally for this part of the process, which is its engagement with a broad range of stakeholders. So they convene citizens advisory committee and different oversight committees for each of the dredge material containment facilities that they've got. So they've built a kind of public around this issue. And have kept the community involved because of the scale of the landscape. They've built kind of a public to participate in it as well. And so looking at what the opportunities might hold in terms of reusing this material, we started by looking kind of at a suitability analysis, trying to understand, okay, well, what do we have left? How much more time is left in terms of filling up the existing dredge material containment facilities? And each has about 20 years left, a little bit more in Masonville. And the state has a rolling mandate as part of this structure, this dredge material management plan. There's a structure in place that there has to be a 20-year rolling capacity plan for dredge material containment. So, looking at this, there's enough capacity, but always you got to look over the horizon when you're thinking about this stuff. And so we looked at other areas that might serve as capacity, increased capacity. Looking at sea level rise. So if you're looking at the map on the right-hand side, what you're seeing is actually projected kind of 3 and 5 foot sea level rise scenarios over some of these terminals, which you'd want to raise them. So we kind of said, well, if all of these areas, or a number of these areas that are projected to be inundated in between 3 and 5 foot sea level rise, what could we do? Could dredge material be part of a solution in terms of raising all of these sites 5 feet? To kind of push them up and out of the flooded areas. And ultimately, I think when you add up all these numbers, that kind of increase the overall kind of life capacity of the dredging program by something like 18 years, which is like a nice number, but again, in a lot of ways, this is an ideal scenario. Obviously, this isn't going to happen immediately. Some of these sites are privately held terminals. Port includes kind of privately held terminals and publicly held terminals. So this is a planning exercise that obviously isn't really going to give the port all of its needs. So what might that look like if we looked inland area, thinking everything at the coast is cheaper because the more you move the material, the more expensive it becomes. And so first looking at the kind of our order of operations was, let's look at the the coast first, and let's look inland. What might we do in an inland basis? And so we looked at things like brownfields. If we wanted to cap brownfields, what might that look like if we wanted to use, and those are all the essentially the plus signs here, the orange pluses. These gray dots were areas, that slated for, through Project Core and things like that. If we were removing housing, we needed to have material to fill in basements. Could we gain capacity in that way? Are there landfills or quarries that might, so landfills are red, quarries are purple, that might, serve as sites for increased capacity. So we did kind of this planning study for capacity. And then we kind of zeroed down to, okay, what about at a landscape level? What might this look like? And developed a suitability model that we've since kind of really, I think, dialed in with DNR to look at, essentially to identify shoreline locations that had the right bathymetry, the right topography, the right adjacencies in terms of land ownership that might serve as a specific site for reuse of dredge material that could support coastal resiliency, ecological restoration, and ultimately kind of help prevent, again, coastal flooding. And so if you're looking down at the bottom right-hand corner, one of the hot spots was an area down in Turner Station. And so we brought that idea to the community with the port, of course, and they were pretty excited. They have been participating in the Citizens Oversight Committee, some of them on the Innovative Reuse Committee, some of them on the harbor team for many years. So they were well primed. Like they don't, unlike my mother-in-law, who when I told her about like dredge material, she was like, what that stuff from the harbor? Like she was she was almost like gagged, like that stuff? But the folks who are embedded in the process really understood that this was a pretty clean material. The port and MDE have testing protocols to make sure that the material is kind of meeting EPA standards. And so we went out there and we toured some facilities and looked at a specific project called Fleming Park, which essentially has been impacted, the shoreline in Bear Creek, which is this area here, so kind of between Sparrows Point, Trade Point Atlantic, and the Dundalk Marine Terminal. This body of water is one of the more impacted waterways kind of in the region, and so it's got a whole bunch of residual metals in the benthic environment, and so we actually saw that as an opportunity because the dredge material then could in some ways serve as a cap. We could use it to cap some of the benthic, substrate. And there was obviously a large shoreline relative to some of the other parks in that area. And so we focused the energy on this park and what we might do in kind of a flood risk and sea level rise scenario, storm surge and sea level rise scenario to protect against that using dredge material. And so we studied the site, fairly typical kind of site analysis at first to understand, well, what are the programmatic uses for the site? What are the environmental uses? How might we begin to enhance this park, both as a place, but also as kind of an asset for flood risk reduction, and also innovative and beneficial reuse of dredge material, trying to kind of pull out the inherent intelligence of the material to do something good for the community and for the port and kind of local stakeholders. And so one of the other things that we found when we were out there actually was helps from a regulatory perspective is that there was an existing kind of pile structure that used to support a pier, and this is a photograph that one of the community members, a guy named Larry Bannerman, shared with us, that this structure actually used to support pier, folks in the community would use for fishing and crabbing and all the other kind of recreational value, and so it was an interesting thing from a kind of cultural landscapes perspective, but it was also useful from a regulatory perspective because the waterway here also, again, it kind of has structures built into it. So getting into the nuance and maybe of the Army Corps' water permitting process, if there's a structure in place, you're not taking water from the U.S., so it makes kind of doing something there a little bit easier. So we were evaluating the shorelines and then looked at kind of the bathymetry for this kind of sweet spot in the intertidal zone. It's a little hard to see here, but you're looking for these intertidal areas, which is kind of the sweet spot ecologically for kind of wetland restoration. So what you're seeing here is kind of a relatively So this is kind of the thinner the line, the more shallow the bathymetry. So it's really a shallow, very shallow kind of profile out through here, which means that there's a very thick intertidal zone. So at low tide, that area is exposed to oxygen, and at high tide, it gets covered. So that tidal exchange is ultimately, helps filter pollutants, helps support a broad range of kind of ecological assets. And so that proved to be kind of a really great spot for the use of kind of thin layer placement, those types of intertidal areas that are looked to in terms of spraying a thin application of dredge material into these areas to kind of move them up and thicken them. So we kind of thought about the idea essentially of kind of combining boardwalk structure with this thin layer placement containment structure, so that when you spray in the sediment, it doesn't wash back right into the waterway, and essentially proposed creating kind of this hybrid landscape that would try and cap the local pollutants, protect the shoreline, preserve that historic structure, engage the public in kind of education about storm surge and help kind of increase their resiliency, general kind of resiliency, and then the overall ecological value. And so this was kind of the plan that we've proposed and has since been kind of submitted by the community to the Army Corps' pilot project, kind of, it's called the USACE Section 1122, pilot project, very technical kind of stuff. But the community's jumped on this. They've got letters of support for this project from congressmen, local representatives, Baltimore County. They have kind of taken this on as their thing. They want to see it happen. They're advocating for this. There's an article in the Bay Journal about it not too long ago. And so we kind of have been helping move this project along, and it includes essentially kind of a restored wetland area and boardwalk that would be used again for kind of educational community gathering, but also as a containment structure for this sprayed in kind of thin layer application, kind of enhancing overall kind of ecological diversity at the edge, which is currently stifled by Phragmites. You barely can see the water when you're actually at the park, because this huge wall of Phragmites that you kind of see when you get there. And so we have different thicknesses based on the bathymetry, different thicknesses of kind of placement to kind of get us back to that sweet spot, again, in the intertidal zone. In terms of a section perspective, what that might look like is kind of reusing some of these pile structures with coir logs as containment. Again, kind of a high marsh area where we're spraying in a little less dredge material. It's lower marsh area where we're thicker profile, and then maybe kind of a zone of kind of substrate improvement where we're kind of capping that piece. And we also proposed as a Head Start program in kind of one of the Fleming Senior Centers over here, and so we also proposed using the dredge material to create a play mounds, essentially using it as a fill material, an accessible fill material that we could use to kind of create some landforms for play structures, and overall kind of cap it with a rubberized surface to kind of create, again, this added value to the community. So jump through some of this. Actually, we can talk about this stuff. I was just going to skip to the end, but yeah. So this is kind of us thinking about this kind of in again this integrated way where we're looking at the kind of social ecological value of the material, the experience of using this, the methods that we might use to bring about this type of a project, and kind of capturing and utilizing the material that's available as a resource in a lot of ways here that for a long time has been kind of looked at kind of quixotically in terms of it's both a great thing and a terrible thing. It's like this. So we're trying to look through this from a perspective of a designer who's trying to connect the dots and see kind of this synthetically. And so again, we played this out, testing what might some first steps be in this process. It's a big leap to kind of go through this. There isn't an urban thin layer placement project. Regionally, there have been some good projects down in the Blackwater, out in kind of a wildlife refuge, but doing this in an urban environment, it poses different challenges, and not, one of them is certainly kind of getting people up to speed. People who were supporting this project on the community level participate, but not everybody will get it. I'm sure there will be questions, and so, we tested against some of these seed balls. We did mix up some cement with dredge material in terms of kind of looking at what these slump tests might reveal to us in terms of the overall quality of this structural quality of the material. Watch this stuff grow over a period of time, and have been looking at some of this material even more kind of specifically testing different types of plant material. The top right is actually an image of what the port has, kind of a little nursery that they have running out at Cox Creek. We've got our own trial in our office testing different plant material. How does it grow in terms of what's the germination rate for things like panicums and hibiscus and other types of species. So what can we grow in this material, again, natively, looking at species that really tolerate low pH, a lot of clays and silts, to try and come up with a palette that can really succeed in this space. So it's one thing to kind of think about the material and the experience, and then there's the methods that get us from kind of big ideas to actual implementation. So we've been trying to, with our partners, again, the Port and MES and Cornell and a range of partners, to try and get through this kind of, zooming out to think about the possibilities, and kind of funneling down to kind of get to a point where we can actually build one of these projects in a way that celebrates this material, kind of capitalizes on it as an asset, through kind of a specific set of methodological kind of investigations and research questions, ultimately to enhance the overall experience of living and kind of working and hopefully playing kind of in this estuary. So with that, I'll leave the question answered. Again, so just quick before we jump into the questions, so this is Kristen Keene. She's the program manager for the Innovative Reuse program at the port. So she has a lot of good knowledge, so you can pepper her with questions too as much as you can me. So I think Sarah will jump in first, and Jeremy.
I have two questions. One, the first pictures that you showed of
Hart Miller, yeah.
Remind me a lot of the lagoon in Venice. It's very flat, and it's that same murky mix of ocean, like salt water, and then river water, and so Baltimore has always reminded me a little bit of the traditional lagoon. And I didn't know if you did any research on, because they constantly do the green. Cruise ships, they have to deal with that same issue. Is that accessible?
So I guess I'll step back and just quickly say, so this is like a very small fraction of the work that we've been doing with the Port and Cornell and DNR actually more recently on dredging. And so there's a whole, we've been working very closely on this on a pilot project for Hart Miller Island, and there's a whole set of challenges associated with that. And so so we didn't look at the at the Venice Lagoon as a precedent here, but the point that that this is a global challenge for any port city. Any port city with sizable enough ships is going to have this as an issue. So you have this different issues. Depending on where you are, the material is going to be different. You may have more sands in it than we do here in Baltimore. We happen to have like a very difficult mix of like some spots where there are some legacy contaminants, not a lot. And this funky silty clay stuff. So we looked at like Rotterdam has some interesting, does a lot of really interesting things. Europe has a lot of really great interesting examples. The Dutch do a lot of really good work with this type of landforming. There are other places around the country that are what called like Army Corps proving grounds, so areas where the Army Corps down in Louisiana are doing kind of marsh terracing. There are precedents that we pulled from around the country and also internationally to kind of help inform our work here.
The second question builds on what you said about the Dutch, because the West Eight governors I went through
Sure.
similar, this idea of building up using dredge material to create higher land elevation for flooding, et cetera.
Yeah. Jeremy.
Just a quick question. I love the idea that any infrastructure project has also a social infrastructure component. So who pays for what, though? Because, I'm also always concerned that the city too often sees any infrastructure project as having to be the least expensive route. So obviously there's value added, money added. So
I'll jump in, and then you want to. So I'll jump in. We'll give you the night off, or you jump in if I'm like. So there's a federal standard. The way this stuff works is there's a federal standard that essentially is the Army Corps' minimum requirement for placement of dredge material that is safe for the public, economic, feasible, etc. And that's open water placement. That's essentially putting the material in the bottom of the sea in a deep place, and that's what it is. Maryland has higher standards, and so there is a cost share that is required of the state to deal with that overage, essentially, from the federal standard.
To place material into our human facilities. That's around $21 a cubic yard. So when you think about that, there's around 1.5 million cubic yards of material shrinks just from the Baltimore Harbor channels alone. So that pays for the operations and maintenance and life of our facilities to house their material. Other private projects and things like that can go into the facilities as well, but primarily the function is to supply capacity for the federal channel maintenance, because those are the channels that are bringing in those Panamax and post-Panamax ships into Port of Baltimore.
And that's a federal, right? That's a federal priority. So that's like the Army Corps. One of its key, core objectives, core mission objectives, is summed up nicely by Graham McAllister, who's one in the Baltimore, to keep boats afloat. Right, like that's their shorthand. It's a very pithy little thing, but so they are responsible for these federal navigation channels because they are in the national interest, national commercial interest of the country. Yeah.
So about the channel and the sediment, is the channel filling up at a rapid rate, fast, or is it more about getting deeper in water?
Yeah, jump on, go for it.
So the channel, different segments have varying shoaling rates in which the sedimentation is accelerated in some areas compared to others. Baltimore Harbor specifically has really high shoaling rates just because of the surrounding land use activities. So every year the Army Corps surveys all of the segments of the channels, and there are some segments where they don't need to dredge them for 9 to 10 years, and other segments that need to be dredged every single year because of the high shoaling rates. So a combination of those annual hydrographic surveys in combination with communicating and coordinating with the pilots association help us to determine the areas that are the highest priority needs for dredging. So the sediment gets there just through a combination of wave and tidal energy and runoff from the land. And the way we like to describe it is, whenever it snows, you have to plow your roads, but snow melts. Every year we have to plow our marine highways, but unlike snow, the sediment doesn't melt, so we have to do something with it.
There are also they're also capital projects. So that's the maintenance channel stuff. Like that's just what you have to do to keep the channels open. And then there are capital projects, which like when the port was preparing for the expansion of the Panama Canal, for these post-Panamax 50-foot wide deep draft vessels, there are projects ultimately that require expansions of the channel beyond what is current, and those get authorized and then appropriated and then built, and those are different than the maintenance channel dredging that and have a different sediment profile than the maintenance channel capital project. They're very different in their nature.
And the Port of Baltimore is one of the few ports in the Eastern Seaboard that already has 50-foot channels, because the largest carriers in the world right now need those 50-foot channels. So we're in a very good position to get some of that, get the business, like the global carriers, to come to our port because we already have those very deep channels, and because, like Isaac mentioned in his presentation, we're the most western located port on the Eastern Seaboard. So it takes ships an additional day to travel up the Chesapeake Bay, but they actually save money in the long run because our intermodal system is so western that we can get goods out to the western markets faster than any other eastern port.
Yeah, Fred.
Yeah, I know Lisa Municipal Cove, if I remember right, what the end state of that facility would be is new terminal, right?
Correct.
New harbor.
Yes.
So that, it's just always been fascinating to me that the port administration can build new land and turn around and lease it too. It becomes a facility. Does that factor in? You do all this revenues or value models when you're figuring out what to do with the material?
Well, not necessarily. Every, like Carmelo Island, Poplar Island, those are habitat development projects, and we're unsure of the fate of, Cox Creek, for instance. But Masonville, because of its position where it's already directly adjacent to other terminal space, the port is the #1 automobile terminal in the United States, and we are increasing our numbers every single year for picking in containers. So because Masonville is right there, it makes sense to pave it over and have additional terminal space. And, we did take some in-water to create that DMCF, but we also completed a significant amount of remedial activity and pages of mitigation to account for that taking of the in-water to help build a
Our
facility.
fellows on the citizens side.
Okay,
Ready for
so
that, yeah.
So
But,
I also,
yeah, it just really, it varies. Like some of it is based on needs of the port and some of it is just based on the situation surrounding land use. So for instance, Hawkins Point is a former dredge material containment facility north of Cox Creek. And the northern part of that, we planted it at 218 native trees per acre, and then we turned it into a mitigation bank. And then the southern cell of Hawkins Point, we're actually filling and grading it right now at this time to construct an outlet flowway to help us get credits in the nutrient trading program for TMDL credits. So that facility is, the end use is something very different than being paved over like what will be a Masonville Cove in about 20 years. Or not the Cove, the MCF.
and I think some of the economic calculus, I think it's Laura Wagner. Laura Wagner, I think, is from UMCS, who did some of the economic. So some of this is also like a cost avoidance. So because waterfront property is becoming more and more of a premium here, the cost to build these facilities, these dredge material containment facilities, is increasing. And so that's part of the economic modeling of saying, well, the cost to build a new one is going to be increasing over time. And so the cost to do beneficial use type projects becomes essentially, it becomes more equivalent. There's a greater equivalency in saying, well, previously the DMCF was a great way to go, and it's still, there's still a lot of capacity left, and it will still happen that way. But it's going to get more and more expensive as projects like Port Covington and others, as these types of maritime industrial uses kind of rub up against, residential, commercial.
One more question. I have another. Go ahead. No, go ahead. First. I just want to know, maybe I didn't hear, your experience with brownfields, in the harbor or in dredging. I guess primarily.
I'll punt that to Kristen.
I know there's limited amounts of there's some land in the area that are brown, but I'm not familiar. So my question to you is, have you been working in that area? Very costly, because I know it's pretty, I guess, dangerous, radioactive, a lot of toxins and so forth. So what's your experience with brownfields? I guess in Baltimore Harbor.
Right. So we don't have experience with brownfield remediation. That's more of
Yeah, but I can also see that mitigation, and when you're digging and you're going in, that can cause, a health factor. I mean, within the garden itself, so I can see it being really kind of, how do I say it, complicated and somewhat perplexed if you're not if it's not taken seriously. So I'm saying, I can see it being possible, as well as transportation.
So the Maryland Department of the Environment, in collaboration with the port and the stakeholders at large, was it last summer, kind of completed a new guidance document to that includes screening criteria, that includes categorization of the material, that says, there's category 1 material, which you could use in your backyard for anything. It's the same as 100% clean fill material. There's category 2 material, which can be used as a cap, essentially, for other polluted sites, and then there's category 3 material that needs a cap of its own. It's material that you can still use in kind of commercial built environment, but it needs its own kind of cap. And there's category 4 material that maybe was going to be part of a capital dredging project that includes legacy contaminants. If let's say Sparrows Point wants to expand its berth and it's digging up all kinds of heavy metals from the Beth Steel days. So there's a criteria and a set of guidelines and a flow chart, and it is complex, that MDE essentially is ready to say, well, you have a project, if you need fill material and you're thinking about using dredge material, here's your pathway, your compliance pathway to use the material in a productive way that again can support public health and well-being. So it is. This stuff is nothing but, if not complex, that's 100% correct. But the regulatory environment and the political environment, Governor Hogan issued an executive order in 2017 about waste reduction and resource recovery that specifically calls out the innovative and beneficial use of dredge material. So the political and kind of regulatory climate is ripe for more projects like this to unfold, and again, community acceptance is growing. There's still the need to kind of pull off a project and do it and kind of show the pathway and kind of say this is exactly how it's done. And that always really helps in terms of developers, designers, the professional community at large to do this kind of work, kind of mainstream it in a way. So it's a good time to be doing this kind of work, and a lot of credit to the government and kind of industry community.
And I'm not sure exactly the location of itself in the country, but I know there has been the redevelopment of ground.
Sure.
And it hasn't been done. I forget which location, which area in the country was successful. And simply, we're talking, small communities where now folks are experiencing
Any other questions before we wrap it up? Chris?
Going back to your example, Lemon Harbor, talked about demonstrating the tidal flats, how you saying that that's where you noticed it was exposed for low tide? You're saying you just chose that spot?
Yeah, the intertidal zone is kind of the area with a really rich ecological kind of. It's a really rich ecological area because it has this tidal fluctuation. So at times it's exposed to oxygen, at times it's covered, by the water, and it doesn't have it. Thickening that area becomes kind of the zone of intervention. I mean, you can do things in different places, but if you're increasing the function, if you're increasing the area of the intertidal zone, you're, as the general rule of thumb, you are increasing the function of the wetland. And it happens to be in this particular example, that area right now is very overrun by Phragmites, invasive species. It's not a healthy intertidal area, but it is a large intertidal area. So it's an area that could benefit from this type of kind of thin layer application and restoration, removal of invasive species, and essentially kind of this thin layer application that would essentially put a new layer of material over top of this kind of polluted substrate that could grow back a healthier wetland ecosystem.
That's awesome. Is it possible to, with this material, create brand new intertidal flats, not building on existing
you could, in theory, I think that gets, again, all of this stuff, I guess I kind of half-joked it before, but like all of it is complex in that way, because then you're getting into, well, what, if you're putting material in open water, in this case, again, we have this situation where it's, that open water has been changed previously, so it gives us a little bit of flexibility, but every time you're putting anything in open water, you have to consider, well, what is that environment now? What kind of marine organisms does it support? Does it have submerged aquatic vegetation? Those types of things. And so it's not always, even if you could, it's not always feasible, from a regulatory perspective to kind of create new intertidal areas. One of the questions that, I think we'll have to address at some point in this project if it moves forward, is essentially, so one of the things that might be really valuable to do is actually creating kind of a larger landscape berm in this area as flood risk, as a flood, barrier, as a soft flood protection structure, so those types of things, so yeah, you're asking about, well, could we create more intertidal zone by filling in areas out here? Maybe. It would totally depend on the very specific circumstances of that environment. You'd have to take soil borings, you'd have to do kind of an environmental impact assessment, study that. But you could, so in terms of like imagining what else is possible, even in this specific example, how we might improve this design, again, this project might benefit from kind of a more of a larger berm to protect against kind of a flood, storm surge. Exactly. Yeah, so these are the kinds of things I think that, like, as these projects move forward, again, the community has been incredibly proactive about getting letters of support from elected officials, submitting proposals, grant proposals, etc. Some of those details will get ironed out, and then it could serve as a precedent for other projects like this, in the Baltimore region. And again, if you zoom back for a quick second, maybe this is a good place to kind of land. Is that there are a good deal of areas, like, when you look at just the Baltimore Harbor, there are a lot of areas where this type of approach kind of might make sense in the Middle Branch, other areas, in and around some of these terminal spaces, and even in the Baltimore Harbor, there are spaces where this might be an effective strategy. So there are opportunity sites, and this is just focused on the Baltimore Harbor. We ran a similar suitability study with the DNR to look at other kind of low-lying coastal areas. So the applications are pretty broad in the Chesapeake Bay region for kind of beneficial and innovative reuse. So it's an exciting time. I'm really thankful for the partnerships with all of the agencies, because this doesn't happen without a lot of collaboration across departments, nonprofit, government, private sector. So we still have a lot of way to go, but.
And I'd like to add that, previously there was a really big stigma attached to dredge material because of all the historical legislation that existed in the Baltimore Harbor before the Clean Water Act. And through years and years of a very robust stakeholder outreach and education campaign, the Port and its partners have been able to successfully sort of re-image the way the dredge material is discussed in the community. So this whole Turner Station group and the Floating Park project really represents a significant paradigm shift in the way in which communities view dredge material. Before it was, no, we're going to sue the state for Hartmiller Island because we do not want that nasty material near us. And now we have this community that's actually asking to use harbor dredge material. So it's a really different climate for reuse in the Baltimore area. And Isaac and his team at Mahan Rykiel have done such an excellent job at really bringing these conceptual level ideas to life and being able to show our advisory committees and stakeholder groups really some of the possibilities associated with dredge material. And without his team, they wouldn't have even submitted a project to the Section 1122, for the program. So this project, among others, are ideas that his team and the interns that they work with and bring in have helped our stakeholders and communities to see all of the different possibilities associated with dredge material reuse.
Well, it's a good place to wrap up. Yeah. What's that? It's true. Thank you, guys. Thank you.